Last problem for sample and population proportions. A survey firm claims 50% of adults prefer online shopping over in-store shopping. A random sample of 300 adults found 168 who prefer online shopping. We're going to test the claim that the true portion differs from 50%. So it's not more than 50%, not less than 50%, either or. Could it be less or more than 50%? Is it just different from 50%? So our null hypothesis right now is that our null hypothesis is that the portion of people that prefer online shopping over in-store is 0.50. We are going to test that it's actually different, that it could be larger or smaller than 0.5. So we're going to use a not equal to 0.5. If we just want to know if the actual population proportion is different, that it could be either larger or smaller, we're going to use that not or equal to sign, and it's going to be a two-tailed test. And that means we're going to have to do one more step at the end to get our p-value, which I'll talk about then. But regardless, we need to get our p, our standard deviation, and our p-hat. The p we're going to use is our null hypothesis, the status quo that we believe is true. We believe that 50% of adults prefer online shopping. Our standard deviation will be the population proportion times 1 minus the population proportion over our sample size of 300. So the square root of 0.5 times 1 minus 0.5 divided by 300. We will use 0.028868. That'll round up to 68. Our p-hat is our sample proportion, so we need to go find the data in our problem that is about the sample. And I see that 168 out of the total 300 like shopping. So we're going to turn that into a decimal real quick. And we will use 0.56 as our p-hat. We now have everything we need to go get our z-score or z-statistic, and then to go get our tails that we need. So to get our z-score, we're going to take p-hat minus what we think is true of the population proportion, the null hypothesis of 0.5, divided by that standard deviation we calculated. 0.56 minus 0.5 divided by 0.028868. We will get a z-score of 2.0784. Now, this is a two-tailed test. So what we're going to do is we're either going to go grab only the right tail or only the left tail and then multiply it by 2 to get our p-value. But how do we know if we're going to grab the left or right tail and then multiply that by 2? If you have a positive z-score like we have here, we're going to go grab the right tail and double it in order to turn that into our p-value. We're going to have to do a little bit more work to get our p-value this time. But since it's a positive z-statistic or a positive z-score, I want a right tail. If that came out to negative, I would have wanted a left tail instead, and then I would have doubled that. So we're going to follow the sign of the z-score. If it's negative, you go grab left tail to double it. If it's positive like this problem, we're going to go grab the right tail and double it to get our p-value. So I'm going to take 2.0784 to my spreadsheet. Let me type that in, 2.0784. Oh, this happens sometimes. Let me just restart my Google Drive. Sorry, guys. And okay, good. Now that worked. I don't know why that doesn't update all the time. So like I just said, I'm going to go grab my right tail out of this problem, 0.019. And I grabbed the right tail because, I have a positive z-score right there. And I got 0.019. Now, if it's a two-tailed test, I don't have my p-value yet. When I just had a left or right tail test, I was done when I got my left or right tail. I had my p-value. For a two-tailed test, we need to take the tail that you grabbed times 2, because it's a two-tailed test. 0.019 times 2. So my actual p-value I'm going to use for this problem is 0.038. And I grabbed the right tail to double because it was a positive z-score. If this z-score had been negative, we would have grabbed the left tail and multiplied the left tail times 2. Now I see here that my p-value is smaller than the alpha that the problem wanted us to use to test at, a 0.05 level of significance. When your p-value is smaller, we have statistically significant enough evidence to reject the alternate hypothesis in favor of the alternate hypothesis. So we would reject the null hypothesis that it's 50% of people prefer online shopping, and we would actually believe it is either larger or smaller than that. All this is saying is that we have statistically enough evidence to reject the population proportion of 0.5. If your p-value would have been larger, we would have failed to reject. When the p-value is smaller than the alpha, we reject the null hypothesis.